So let's show you how to set these up in more detail, because that one was a bit complicated to run through, but just kind of gives you an idea of where you can go. Let's run this one. This one's a simple enough one to start with. We have a pulley system. We want to try, we need to design all these different types of pulleys, but we want to avoid certain natural frequencies when we're doing the design of these pulleys. So how would we go about that? Well, we would have a sensor monitoring the first few mode shapes of each pulley, and we'll have a design study increasing the number of spokes and evaluating all those options for us. So here we have a very basic pulley set, ready to go. We run a frequency analysis. Thought I did anyway. It'll only take a minute to run. So it's made of alloy stainless steel. We're going to mesh, and it's looking at the first 5 mode shapes. So you can see it's running at 113 hertz here. 342, 343. I can animate that just to show how it vibrates, shakes, swirls, and rolls in its natural state without any loads. Now we want to run some scenarios where we need to enter the variables as far as changing the number of spokes. And we want to monitor the natural frequency. So we do that by entering a variable. So we have a parameter. You can give it a name. I'll just go ahead and create one here. I'll call it angle 1. It's going to be a dimension on our model, which is going to be the dimension of the actual I've already set this one up, so it's going to be that angular dimension which shows how far that thing has moved. So that's what I put in for the first one. I'll just start a fresh one. That'll be easier. Create a new design study. Add my angle parameter. So we can try out all the different variables here. 180, 120, 90, 72, and 60. So that way I would just go ahead and put in those discrete values. And I can type them right in here. 180, 120, 90, 72, 60. Just type them in separated by commas. Then the constraint is just going to monitor the frequencies. We're not going to optimize anything, we're just looking. So I'll just add each of our frequencies in here. And I can say monitor only. And I don't need to give it a goal. I can uncheck optimization, just hit run, and it's going to go ahead and just try all these out for me. And you can see now that it's running, I can look at my results list and look at my natural frequencies. This is measuring it in radians per second, the way I've set up this study. But it could be in hertz as well. But, all that information right there at your fingertips. And you, as the engineer, can now decide where you want to go. There might be a certain frequency range you need to avoid because the machine is running, there's a motor running at a certain range. And if you want to actually look at the results of scenario 4, You just go right over to the tab for the actual analysis, and you can actually look at the detailed results. They're all loaded. And of course, you could save that as a report, play the animation, share it as an e-drawing. So that's running a design study using frequency parameters. Pretty easy to do, isn't it? You can do the same thing to optimize shapes for bracketry. All sorts of different things can be optimized for shape. You have it vary a dimension. Define a goal. For example, you might want to minimize mass. Minimize weight. Minimize, maybe you want the center of gravity to be in a certain range of, certain area. That can all be set up with sensors.